Right, so here is one problem. We're going to go through all the different things that we've learned about absolute value graphs. So it wants us to find the characteristics, which means that it wants us to use all of those different descriptors that we've been talking about basically all week. So first I'll go through the transformations. The 2/3 in the front, 2/3 is smaller than 1, so that's a compression. So this is a vertical compression of 2/3. The graph has gone to the left 5 and down 7. And I can go ahead and state the vertex because I already know what it is. So the vertex would be the opposite of this number, so -5 and then -7. Sorry, I wrote that where you couldn't see it. Vertex is -5, -7. All right, now before I do anything else, I'm going to go ahead and graph this on Desmos so that I can refer to the picture of the graph. So y equals 2/3. I just typed it in as 2 divided by 3. I'm making sure to move my cursor over before I start typing the rest of it. So I can see that my vertex is right there at -5, -7. And then from there, I'm going to go ahead and zoom in a little bit just so it's easier to see where it crosses. So it goes over 3 and up 2. Over 3, up 2, over 3, up 2. So that's what I'm going to graph when I draw it. I'm going to go ahead and find my x and my y intercepts now, just so I can do everything with Desmos all at once. So there's my x-intercepts, -15.5, +5.5 for the x-intercepts, and the -3.667 for the y-intercept. Okay, so left 5, down 7. And then we said it was over 3, up 2. All right, and I'm going to go ahead and write down the x and the y intercepts now since I already found them. So we were going to have to graph that one anyway, just because the x-intercept, we knew that there was going to be one over here, but we couldn't see where it was. So we were going to have to graph that anyway. And the y-intercept was -3.667. Okay, so some of the other things that we have found as characteristics is the domain and range. So we know the domain is always from -infinity to +infinity. The graphs for absolute value functions always go left forever and right forever, so that's pretty simple. The range is from the bottom of the picture to the top. So the bottom goes down to a y-coordinate of -7. That's the very bottom. And then the top of the picture is an arrow going up. That's a +infinity. We do brackets for the number and parentheses for the infinity. I also want to find the increasing and decreasing intervals. So I'm going to go ahead and draw my stick figure. He's starting right here at -infinity, and he's walking downhill to start with to an x-coordinate of -5. And then after he hits that x-coordinate of -5, he switches directions and then is going uphill to the right arrow, which is infinity. So my increasing interval is from -5 to infinity. And my decreasing interval is from -infinity to -5. Okay. We also want to figure out if there's a max or a min. So the max would be the highest point on the graph. The min would be the lowest point on the graph. There is no highest point on the graph because there's just an arrow there. This graph goes up forever. So for max, I'm going to say none. For the minimum, it's the vertex, which was at -5, -7. I already did the x and the y intercept. I also want to determine if this graph is continuous. And that means, can I trace it with my finger? So I'm starting on the left side. I traced the whole thing with my finger without picking up my finger. So that means, yes, it is continuous. And then last, I want to do my end behavior. So as x goes to the left and as x goes to the right, that's what we want to look at. So as x goes to the left, the arrow is pointing up, so y goes to positive infinity. As x goes to the right, as we look at the right arrow, the arrow is pointing up, so again, y goes to positive infinity. So by the time we get to the end of this packet, this is the goal, that I could give you an equation and you could find all of these things for that one equation that you would use to describe it. Because once you can describe something, you can talk about it with understanding, and these are kind of the building blocks for you to be able to deal with any function down the road. And these are the types of things you have to understand if you choose to go into more advanced math after this.